So this is the mock paper, which is the May 2013 paper. Okay, we're going to go on to question 1. In question 1, you have a mass of an elephant, which is 10 to the 4, and the mass of a mouse, which is 10 to the minus 2. And you need to work out the ratio of those two. So it's simple division. 10 to the 4 divided by 10 to the minus 2 will give you some indices that you have to subtract. Okay, so it's 4 minus 2, which is the same as 4 plus 2, which is 6. So the correct answer is C. Question 2. 2 identical balls are dropped from a tall building, one a few seconds after the other. Air resistance is not negligible. As the balls fall, the distance between the balls will, or what will they do? Well, if we consider, the first ball will begin to accelerate immediately, but as its velocity increases, you'll find that the air resistance will start to build up, and so therefore its acceleration will decrease until it gets to a point where the acceleration equals 0, and at that point the velocity is constant. Okay, the other ball, which starts its journey a little bit later, will do exactly the same thing. So there'll be a time at the beginning where both balls, A and B, are accelerating. Now, A is accelerating, or will initially be accelerating at a larger rate than B, so initially the distance will increase. Okay, but as they both tend towards this situation, you'll get to eventually a point where they are both going at a constant speed, so the distance will stop increasing and they'll have the constant distance between them. So the answer is C. Initially it will increase and then it will remain constant. Question number 3. Which of the following is always true for an object moving in a straight line at a constant speed? An object that's moving in a straight line at a constant speed must have all the forces acting on it being equal and opposite, or balanced. Okay. Now, in the situation where you have no forces acting, it could actually be at 0 or constant. So this isn't specific enough. The answer would be B, no resultant force acts on the object. This is actually Newton's first law. Okay, so we have two objects, and we need to work out what the work done against gravity is for both of them as a ratio. Object A, which has a mass m and h as height. Object B has a mass of 2m and a height of 4h. Now, it states clearly that the gravitational field is constant over the height interval. That means that we don't have to get into complicated formulas. We can use the standard mgh. And why is mgh the appropriate formula? Because work done is force times distance. The force is mg times the distance, which is height. Okay, so let's have a look at object B and object A. Well, object A is the easiest, so I'm going to start with that. The work done against gravity for object A is mgh. For B, it's 2mg4h. Okay, so if you multiply out these two, we end up with 8. Let's write that there, and we can cancel just about everything else out. So we're left with 8, which is D. Question 5. A horizontal disc is rotating about a vertical axis through the center. Points P and Q on the disc are at distances r and 2r respectively from the center. The acceleration at P is A. Which of the following is the acceleration at Q? So, the thing you have to take into consideration is, because this is rotating on the same disc, you have T, your T is constant. Okay, so your T is going to be the same for P and for Q. Okay, so now let's look at circular motion relationships. Acceleration equals v squared over r. And we can expand we can expand our relationship to include v now. If we know that the velocity of the point on a surface of a circle, its velocity is 2 pi r, the circumference, divided by the time, that's v. V squared then would be 4 pi squared r squared over t squared. Okay, so now we need to substitute this back into our original formula. So we have a relationship for acceleration which is equal to, we think this r is going to cancel with one of those r's, so we're going to end up with 4 pi squared r over t squared. Now, if the acceleration of p is a, what's going to happen if we now increase the radius by doubling it? Well, let's have a look at our formula. If we double the radius, okay, the only thing that's going to happen to the acceleration is that it will double as well. Okay, so the answer is C. Okay, so we have a specific heat capacity question, and this is mixtures. We've got 4 kilograms of water at 100 degrees mixed with 4 kilograms of water at 0 degrees in a container insulated from the surroundings. When you mix them, what is the following temperature of the water? Okay, so what you need to do is consider all the energy that's available. You have the energy in the 100 degree water, and you have the energy of the 0 degree water, and basically that's going to be redistributed amongst the mass of the two quantities together. So that would be equal to Q of all of it. Okay, so if we work out the amount of energy each using the specific heat capacity, we have the mass of the 100 degree quantity, which is 4 times C times 100, but we need to consider absolute temperature, so 273 plus 100 plus the energy available in the 100 degree container, which is 1 kilogram, times C times 273, okay, and that's going to be equal to the mass of both of them together, which is 5 times C times, we're going to call it D. Okay. First we cancel out the C's because we don't need them anymore. Okay, and now I'm going to plug all the values into a calculator. Okay, so the next round of calculations gives us this, which if we solve for T would give us a value of T 353, which is in Kelvin. If we change that into degrees, you should see that the answer is D, 80 degrees. Okay, so next question. Which of the following is the temperature of an object related to? And you should know from kinetic theory, simply, it's a definition, the random kinetic energy of the particles in the object. Okay, so that's temperature. If we were talking about internal energy, then that would be different. That would be the kinetic and the potential. But this is specifically temperature. Question 8. A fixed mass of gas is compressed in a very short amount of time. Which of the following describes the process? You should remember from your definitions that if you have a fixed mass of gas compressed in a very, very, very short amount of time, there is no Q, there's no Q transfer. So it's adiabatic. Okay, so number 9, which of the following statements is consistent with the second law of thermodynamics? If your revision is thorough, you'll learn these laws off by heart, and you'll know that it's C, entropy tends to increase in all natural processes. The next question is about resonance. We have water molecules resonating in microwave ovens, and it's pretty much just asking you to explain resonance. In order to heat the food most effectively, the frequency of the microwaves should have a value. Well, resonance happens when the water molecules vibrate at their natural frequency. So it would have to be equal. Remember, resonance happens when the driving frequency equals the natural frequency of the oscillating object. Question 11. Gas particles are equally spaced along a straight line, and a sound wave passes through the gas. The positions of the gas particle at one instant are shown below. So here is our first particle, and what we have to do is find another particle which is in the same situation, it's the same position and moving in the same direction. Okay, so if we look through here, we go from compression to rarefaction, the spreading out. So these waves are getting further apart until here we see them getting closer together. So that's like the second half of our cycle until we get to this point here. Okay, and then after that, you can see that all the particles are going to be repeating this kind of behavior. So we've ended a cycle by using the distance b, and that would be one wavelength. And how would we identify that? Again, by looking at patterns. All of this is being repeated over here, so therefore that's the end of our cycle. So we have a single slit diffraction pattern of wavelength lambda and width of gap b. Which of the following changes in lambda and b will increase the value of the angle? Well, if we think of our relationship, the angle will be equal to lambda over b. And the only combination of things that will increase the size of this angle is an increase in lambda and a decrease in the width. So that would be option D. So two coloured point sources are observed through an optical telescope. Which of the following colours would best allow the images to be resolved? So basically we want the Rayleigh criterion, the angle, to be as small as possible because anything above this can be resolved. The smaller this angle, the more you can see, or the longer the distance, or the better you will see two images, two objects that are very close together. Okay, so in this question, which is the wavelength that will give us the lowest angle possible? So we're looking for something that will keep the magnitude lower. So we're looking for the light with the lowest possible wavelength, and that would be blue. Unpolarized light of intensity I0 is transmitted through a polarizer which has a transmission axis at an angle to the vertical. The light is then incident on a second polarizer with a transmission axis at an angle to the transmission axis of the first polarizer, as shown. The intensity of the light that emerges from the second polarizer is I. What is the ratio I to I0? So if we think about Malus's law, we have I, intensity, equals initial intensity, cos squared the angle. So what is this angle? This is the angle between the two transmission axes. Remember I commented that it's the only real trick to applying this formula if they give you a strange combination of angles. But it does state very, very clearly in the question that the second polarizer has a transmission axis at an angle phi to the transmission axis of the first polarizer. So this is your angle here. And the only logical answer would be part C, okay, which gives you the right angle. Which of the following graphs shows the relationship between current I and voltage V for the filament lamp? Well, these are things that you're going to have to learn off by heart. A filament lamp has a resistance that increases with temperature. So as the voltage increases, the resistance will increase. Now we know that voltage over current, that ratio will give us resistance. So which one of these graphs shows how voltage over current increases? You have to find a slope that decreases. I know it's a bit illogical, but it's just the nature of it. So this one has a slope that's increasing, but that means that the ratio I to V is increasing, and we want the opposite. So the answer is D. Question 19. A cell of negligible internal resistance is connected to 3 identical lamps. A voltmeter is connected across one of the lamps. If the filament in lamp X breaks, the reading in the voltmeter will, let's have a look at the situation. We know that resistance in parallel, if we put resistors in parallel, the overall resistance decreases. Okay, so here we have resistors in parallel. The net resistance is less than the individual resistance. If one of these bulbs breaks, this resistance will increase. Now, what's the consequence of the resistance increasing? The energy that's being distributed to the circuit will change, the distribution will change. You will have more energy per unit charge going to this bulb because its resistance has increased. So therefore, there is less energy reaching this bulb, so therefore the voltage will decrease. Question 20. 2 point charges of size 2q plus and minus q are placed as shown below. In which of the regions 1, 2 and 3 can the resultant electric field strength be 0? Now, you have to use a little bit of common sense with here. There's no calculations. You need to decide which combination is going to give you a possibility of there being 0 field strength. Well, at 1, we are very close to the point charge which has the greatest field strength. So it's very unlikely to be I because we're too close to 2q. In the middle, we can see that there is an unbalanced situation. We have a greater field strength due to this charge than this charge. So you are definitely going to have a net force acting due to this one. And then point 3, you are less likely to feel the influence of the stronger charge because it's further away, okay? And you are close to a single charge, but there's a possibility that at this point its effect might be minimal. So it can't be 1 because you're too close to the 2q. It can't be 2. It can only really be C. A ball of mass m is thrown horizontally from a cliff with an initial velocity of u. A change in which the following... A ball of mass m is thrown horizontally from a cliff with initial velocity u. Air resistance is negligible. A change in which of the following will affect the horizontal distance travelled? Because we're dealing with the horizontal distance, the only thing that's going to affect its motion in this direction is a change in the initial velocity. Okay, m is a spherical mass situated far away from other masses. Which of the following gravitational equipotential surfaces having constant potential difference between them? Okay. Now, in order to draw gravitational equipotential surfaces, we need to draw the field lines for a spherical mass. Now, the field lines are, for a spherical mass, radial. Okay, so they actually look like this. So this discounts option A because our equipotentials do not look like our field lines. Now, what we can see with these field lines is that the field strength is getting weaker as we get further away. So points of equal potential difference would be further apart as well. So our first field equipotential drawn at 90 degrees to the field lines, so that's what gives us the circular shape, okay? These circles get further away because the field strength is getting weaker, okay? So the answer would be C, because you can see the equipotentials are close and then getting further away. Okay, you may ask, well, what about this middle bit here? Why is that empty? Well, if you read the examiner's report, they cheekily justify this as saying that no attempt is made at completeness. It's just the most likely result. So just be aware of that. Sometimes we do get some funny answers, but this is the only logical one because there is an increase in distance. Right, 24, a satellite is moving from low orbit to higher orbit. Which one accurately describes the energy of the satellite? So let's write down our energy formulas. I'm going to write them down here. Okay, this is the relationship for the total energy. This is the relationship for the gravitational energy. And this is the relationship for the kinetic energy. Okay. Now, these minus signs make the whole thing really interesting because if you go from a low orbit to a high orbit, you're changing R, you're making R greater. So on the surface it looks like all of these will become lower, but total energy and gravitational energy are minus. You actually go from a larger minus number to a smaller minus number. So what you're actually getting is you're getting an increase in the total energy because of this value getting bigger. You're getting an increase in the gravitational energy because this number's getting bigger, and you're getting a decrease in the kinetic energy because this number's getting bigger. So the only option that reflects that is D. Okay, which of the following would decrease the initial activity of a sample of plutonium? The only thing that would affect the initial activity of a sample of plutonium would be decreasing the mass of the sample. If you remember, natural decay is only affected by the amount. No external event like temperature will affect it. A dark room would have no difference whatsoever. And placing the sample in a lead container, the only effect that would have is absorption of alpha, beta, and maybe some gamma. But the actual activity will stay the same. Question 28. We have neutron capturing an alpha particle, which then makes an oxygen particle, and that decays to release a proton. Now, what would we call this? It can't be alpha decay, because if it had been decay, the alpha would be on the other side of the arrow. It can't be nuclear fusion, because nuclear fusion specifically deals with hydrogen becoming helium. It's not a proton decay, because this isn't happening naturally. This is happening because of an artificial situation where a particle is being absorbed. So this would be artificial transmutation. An electron that's accelerated from rest through potential difference V has a de Broglie wavelength of lambda. What is the wavelength of an electron accelerated from rest through potential difference of 2V? So let's think of the relationships that we need to consider. We have the first one from the data booklet, which gives us P equals h lambda, where P is the momentum, mv, h is Planck's constant, and lambda is wavelength. So wavelength, if we rearrange this, would be the same as Planck's constant over mv. So we're going to see what is the relationship between voltage and velocity of the charged particle. For that, we need another relationship. That's an energy relationship. The charge on an electron times the voltage which accelerates it can be converted into kinetic energy to give you a half mv squared. Now, if we double the amount of voltage that we have, keeping everything else the same, then the resultant effect on V would be square root of 2. Okay? Because that V term is squared. So therefore, by doubling the voltage, we are changing the velocity by a factor of root 2. So if we put that into that formula there, we are changing the wavelength by a factor of square root 2. Okay, so the answer would be D. A radioactive sample of initial activity 12 BQ has a half-life of 3 days. Which of the following is the activity after 4 days? Well, in one half-life, the activity goes down to 6. In 2 half-lives, the activity will go down to 3. The activity after 4 days would be closer to 6 than to 3, so the answer would need to be 4.8. Question 33. The diagram below shows an energy flow diagram for a car. The efficiency of the car, a very straightforward calculation, is the useful energy out over the energy in times 100. Okay, so if we have a look, the energy out is 30, the energy in is 100, so we end up with 30%. A small biofuel power station burns ethanol with an efficiency of 25%. So that gives us a ratio of 25 over 100. The energy density of ethanol is 30 megajoules, and the mass of fuel consumed is 50 kilograms. So we have a total energy available. Our power input is 30 times 50. Okay, so that's our available energy. Power out over power in. Okay, if we substitute our values in. 30 times 50 equals 25 over 100. So if we multiply this to here, we end up with times 30 times 50, and that gives us option A. In a nuclear fission reactor, the role of the moderator is to absorb neutrons to shut down the reactor. Well, that's not quite. That's too much. If we did that, we'd have no power. Speed neutrons up to increase the rate of energy production. Well, that's not quite, because that seems like a uncontrollable situation. Slow down neutrons to decrease the rate of energy production. Also not relevant. Okay. Slow neutrons down to make the chain reaction more likely to happen. It's D. And you have to be, you're just going to have to learn those off by heart. The role of the moderator, the control rods, the coolant, etc. 36. Carbon dioxide is a greenhouse gas because it absorbs infrared light radiated by the sun. Well, that's a possibility. Sounds good, but let's keep reading. Absorbs ultraviolet light. Now, that cannot be right because there is no relevance really with the greenhouse effect. Its natural frequency molecular oscillation lies in the infrared region. Now, that's an exact definition of how the greenhouse effect occurs. So the answer is C. Which of the following is more likely to increase the rate of global warming? If we use natural gas to start at the bottom instead of coal, well, that's not going to make it better or increase it. It's kind of keeping it the same. If we increase the use of renewable energy sources, we'll reduce the amount of fossil fuels, so we won't increase the rate of global warming, we'll decrease it. You increase the use of nuclear power stations. Well, if you do that, supposedly you would decrease the use of global warming. But deforestation, of course, if you continue with deforestation, you won't be able to reduce the amount of carbon dioxide in the atmosphere. So the answer is A.